ways about solving exponentials and solving logarithms. Because exponentials and logarithms are inverse functions, you will often use one to solve the other. Okay, you will often use one to solve the other. Not always, but you will often use one to solve the other. Now, so the first three problems we have up here are exponential equations. Variables in the exponent, we have to solve for x. Now the first one, actually, we don't need to use logarithms on. And if you don't need to use logarithms, you should not use logarithms. Okay, because often you will come out, your calculators will give you a decimal approximation instead of the exact answer. And we want to be exact whenever possible. So I look at the first problem and I have 27 to the x and 3 to the x plus 1. I look at that, I go, oh, 27 is 3 cubed. I can write them both as powers of 3. When I can write them both as powers of the same number, that's what I want to do. So 27 is 3 cubed. Now I take that 3 cubed to the x power equals 3 to the x plus 1. Well, 3 cubed to the x power and raise to the power to a power. That's multiplying, so I have 3 to the 3x equals 3 to the x plus 1. If the bases are equal, then the powers must be equal. 3x equals x plus 1. Subtract x, 2x equals 1. X equals 1/2. Whenever possible, this is what you want to do. If you can write them so they have the same base, that's what you want to do. You're going to get exact answers. You're not going to get approximations. You don't have to bust out your logarithms to solve it. Okay? But if you look at the next problem, you can't. You can't do that. You cannot write 7. Well, you cannot write 7 as a power of 3 easily. You can. It's extremely difficult, and I'm not going to show you how because I don't want to. There are easier ways to solve this, and it's really quite easy. If you cannot write them as the same base, all you do is take the log of both sides. In this case, take the natural log of both sides. So I end up with the natural log of 3 to the x equals the natural log of 7. And I hear some of you saying, but wait a minute, Mr. Orris, it's still in the exponent. But the rules and properties of logarithms let us bring it down in front. This is why I said it was the most important property you have with your logarithms is to bring this power down in front. So I have x times the natural log of 3 equals the natural log of 7. And remember, the natural log of 3 is just a numerical value. It's like 2 or 5 or 8. If I had 5x instead of x times the natural log of 3, I would divide both sides by 5. Well, here, just divide both sides by the natural log of 3. And I get x equals natural log of 7 divided by the natural log of 3. And you do that on your calculator, and it is not the natural log of 7/3. You have to do the natural log of 7, divide that by the natural log of 3. And you get x equals, is approximately 1.771. In 3 decimal places, once again, standard. Okay? This is what logarithms are really, really, really good for. This is really what you're going to want to do. In order to solve an exponential equation, logarithms are your friend. This is what they are best for. This is the most useful thing by far and away. Because otherwise, you can't do this. Because even trying to write 7 as a power of 3, you have to use logarithms to figure out what that power of 3 would be, and it's really, really, really complicated. It's not worth it. Do this, it's easy, it's a few steps. Okay. The next problem, I have the same thing going on. It's a bit more difficult to do, but I have the same thing going on. Take the natural log of both sides. Natural log, natural log. Bring the powers down out in front. So I have x minus 2 times the natural log of 5 equals 3x plus 2 times the natural log of 3. And this is not pretty. Not by any stretch of the imagination. Okay. Sorry, it's ugly. Deal with it. Okay. So the first thing I want to do is get rid of my parentheses. Distribute. So I have x natural log of 5 minus 2 natural log of 5 equals, and I'm going to run out of room because I'm bright big, 3x natural log, actually I'm going to do this. Normally you shouldn't. X times 3 natural log of 3 plus 2 natural log of 3. Notice where I'm putting my variable and where I'm putting the constant, particularly on the first one, x natural log of 5. Normally when we have a number times x, we put the number in front, right? 2 times x, we have 2x, we have 5x, we have negative 8x. You don't do that with natural logs because you don't want to accidentally assume that you're taking the natural log of 2x rather than being the natural log of 2 times x. Very easy to get confused. Natural logs you put after the variable. If you have square roots, if you have x times the square root of 2, it's x root 2, not root 2x. Because eventually you might think it's root 2x. Rather than square root of 2 times x, you might confuse them and combine them. Radicals you put at the end, logarithms you put after the variable. Okay, and that's just so you don't get confused and start taking the logarithms of things you shouldn't be taking the logs of, or taking roots of things you shouldn't be taking the roots of. That's why we do that. That's why we put the numbers after instead of before. It's just so we don't get confused and start doing the wrong thing. Okay, so get all your x's on one side and all your non-x's on the other side. So I will add 2 natural log of 5 and subtract x 3 natural log of 3, and I know it's hard to read. And you have x natural log of 5 minus x 3 natural log of 3 is equal to 2 natural log of 3 plus 2 natural log of 5. Like I said, it's not pretty. What's my next step? No, I don't do any calculator work till the very last step. Okay, and I'll talk about that here in a second. Factor out your x's. Factor out the x's. I got 2 x's here, so I have x times the natural log of 5 minus 3 natural log of 3 equals 2 natural log of 3 plus 2 natural log of 5. I have x times a numeric value, which means I divide both sides by that numeric value. And I end up getting x equals 2 natural log of 3 plus 2 natural log of 5 over the natural log of 5 minus 3 natural log of 3. And then you stick that in your calculator and you get negative 3.2116. And I don't know why I went 4 decimal places, I just did. Now, why do I wait till the final step to evaluate my logarithms? Round off error. Because if you take your logarithms of your numbers early on and you write down a three-digit decimal for your answer, 5 steps before you're finished with the problem, when you get to your final answer, you may not be accurate to 3 decimal places anymore. If you do your logarithms and stuff early and you write down your decimals early, if you're rounding that off, by the time you get to where you need to be, you won't be accurate to those 3 decimal places you need to be. It's called round off error. And I've seen it on the AP exam where you have something like this, and you take the natural log early, you write out 3 decimal places, and you keep working it, and you use those 3 decimal place numbers that you wrote down, and you get down to the end, and your answer's 3 decimal places, but it's not accurate to those fully 3 decimal places, and you get it wrong on the test. They've actually used those as examples of where students have lost points to drive home their point. Okay, they have the actual questions with sample answers and how they were graded, and they will talk about that. And I've seen that where they said, hey, they rounded off too soon, so their final answer was not correct. If you do something like that, if you do take the logarithm early on and write out the decimals instead, go to 5 or 6 decimal places in your work. Do not round off to 3 until you get to your final answer. That's why I leave everything in natural log form until I'm ready to bust out my calculator and get a final numeric answer. Okay, I never do it before I get to the end because I don't want to end up having a round off here. Okay, and I've seen that on tests that I've given, and I've seen that, like I said, on sample AP questions. And it's technically, it's called round off error. You don't round off to 3 decimal places until you are finally finished. Not some intermediate step. You don't do it till the final answer. Okay. Any questions on this stuff? Basically, that's how you solve an exponential. Take the log of those sides. That's what logarithms are absolutely fantastic for, because otherwise, you can do the first one, you're not going to be able to do the other 2. Okay, solve the logarithmic expressions. We're starting with logs and we want to end without logs. Now there's 2 ways to look at this. Okay, if I already have logarithms on both sides of the equation, which I do, and I have nothing but logarithms. Name it. 5-0, who's busted? Okay. Jorge. Okay. If you have logarithms and nothing else, get logarithm and equal to logarithm, and they have to be the same base. So I look at this one, I have log base 4 on both of them. I want to get log base 4 of something equal to log base 4 of something. I don't have that here. I have the 2 in front. I have to bring that up and make it a power. So I have log base 4 of x squared equals log base 4 of 9. And then this is easy. Log of something equals log of something. Those 2 somethings must be equal to each other. X squared equals 9. Okay. So x equals plus or minus 3, because whenever we're solving, you must consider the positive and negative answer. Okay, when you use a square root solve, just technically we're solving it, right? Because when I take 3 and square it, I get 9. I take negative 3 and square it, I get 9. Both of those will work. Except for, you need to check your logarithms, check the original problem, make sure you don't have an extraneous solution. Remember, you cannot take the log of a negative number. And just because my answer is negative doesn't mean it doesn't work. Also, positive numbers sometimes will not work in the original one, depending upon what the problem is. I have to plug my answers in and see if they will work. I can take the log of 3, that's good. I cannot let x be negative 3. So x is strictly only 3 in this case. Negative 3 will not work. Sometimes both positive and negative will work. Sometimes they won't. Depends upon the original problem. But remember, you cannot take the log of 0 or a negative number. You need to check your answers and make sure they work. Next one's a little more complicated. Okay. I have logarithms, but I have something else. This doesn't work. I can't do what I just did. I can't get log equal to log. What I do need to do, though, is combine them into one logarithm on one side. So addition means that I have log base 5 of x plus 6 times x plus 2 is equal to 1. Log of something equal to a number. loop it. So that means that I have the base of this, so that power, 5 to the first, is equal to, and I'm going to go ahead and FOIL that out, x squared plus 8x plus 12. What do I have? I've got a quadratic, right?
Yeah.
Okay. Well, what's my next step? Subtract the 5, set it equal to 0. 0 equals x squared plus 8x plus 7. Yeah. So factoring it out, 0 equals x plus 1, x plus 7, which means that x equals -1 and x equals -7. Can I use both -1 and -7? No, -1 works fine, right? But -7 will make this and this both negative. On the test, I will be looking for both of those answers being listed as possibilities and one of them being eliminated. Again, Haley. Okay, questions on that one? Okay. So this one here, combine up the first side to one logarithm. Okay, do that first. Okay, you do that, you get the natural log of x times x minus 4 equals the natural log of x plus 6. Log of something equals log of something. That means those two somethings are equal to each other. So x squared minus 4x equals x plus 6. Set it equal to 0. X squared minus 5x minus 6 is equal to 0. Two numbers multiplied give me -6 and add to give me -5. No, not -2 and 3. -2 and -3 multiplied together give you +6. I don't want +6. X minus 6, x plus 1 equals 0. Okay, fatal mistake that many of you made on the quiz is assuming that, oh, if it's 6, it's got to be 2 and 3. Nah, it might not be 2 and 3. You got to pay closer attention. There was several people that made a similar mistake to just that one on the quiz. Okay, just making an assumption. Oh, it's got to be these two numbers. Okay, so that means x equals 6, x equals -1. And I plug them into the original problem. No, it can't be -1, but it can be 6. And -1 will give me a -5 in here. It's good, and also be -1 in the first one. But I can be 6.
So if anything's going to be negative,
Not necessarily, because if I had, for example, let's say this was 4 minus x, okay, or 3 minus, 4 minus x, then 6 wouldn't work because that'd be a negative inside. Does that make sense? So you can't go by whether it's negative or positive. It's a good place to start, but that's not a guarantee. You do have to plug them in the original problem and see what you get. So next one. I cannot do what I just did because I can't get 1 log equal to 1 log. I got something else. If I have something else, I get all the logs on one side, all the something else is on the other side, and go from there. So my first step is to actually add log of x minus 1 to both sides. So I get the log of x minus 16 plus the log of x minus 1 is equal to 2. If you have logarithms and non-logarithms, get all your logarithms on one side first, and all the non-logarithms on the other side. You can't loop it yet till I have a single logarithm, yes.
Oh wait, never mind.
So I do have to combine them up into one logarithm first. So I have the log of x minus 16 times x minus 1 is equal to 2. And now I loop. And I'm going to go ahead and FOIL out. So I get x squared minus 17x plus 16 is equal to, what's the base of my logarithm? 10. So this would be 10 squared, which is 100. Subtract 100 from both sides. X squared minus 17x minus 84 is equal to 0. Two numbers that multiply to give me negative 84 that add to give me negative 17. There you go, negative 21 and positive 4. Ooh, man, that took me a while to get it myself. Yeah, I had to play with it a little bit first, but yeah. So that means x equals 21 and x equals negative 4. Will they work? 21 will work. The negative 4 won't work. Negative 4 will work in this. Well, actually, negative 4 won't work in either one of them. Okay. And I know it seems like if it's negative, it never works. Trust me, it's not always the case. Okay? Questions on this? Ooh, now we're getting to the interesting stuff. Money! Money, 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 money. Money! Okay, compound interest. A equals P times 1 plus R to the N, where P is the principal. Not your principal, but the principal. You know how to spell the difference, right? Because the principal's your pal. No, principal's your pal. That's why it's P. That's what I was taught too. Okay. So your principal, that's the amount you're investing. The rate per period, the amount of time periods. Usually when you're dealing with this, you're dealing with N is how many times per year. Okay. Now, I don't particularly care for this one as it stands. This really only works if it's annually. Okay, and I think that should be a T, not an N on there. So this is what I like to do is I don't like to use this one. The one I like, very similar. A equals P 1 plus R over N to the N T. N is the number of times per year it is compounded. T is the number of years. R is your interest rate. And your interest rate will be written as a decimal. Yes.
So which one was the
We're going to be using the second one more often, to be perfectly honest.
That's not how you get E, just put bigger numbers.
Well, yes. And E would be if you're compounding continuously. So instead of compounding annually, or compounding quarterly, or semi-annually, or monthly, or daily, compounding continuously, which nobody does because mathematically it's easy to figure out what it will be at the end, but at any particular point in time, banks don't like to do that. Okay. There you go. Come on. There we go. Well, banks don't like to give you money anyways.
Yeah, for real.
This actually works well for how much you will owe. Okay. So, compounded continuously, much fewer things, your principal, your rate, your times. That's it. So problem number 8, find the value of an investment of $3,200 at 2.4% interest after 7 years, compounded at different rates. How much money are you going to make depending upon how often it's compounded? Well, you do have to remember the 2.4 becomes 0.024. We don't do the percent, we do the decimal. And then after here, it's just busting out your calculator and figuring it out. So annually would be 3,200 times 1 plus 0.024 to the 7th power. Because n is 1, because it's done once a year. And if you did that at the end of 1 year, you would have $3,700, $3,777.89. Woohoo! You made $500 at the end of 7 years. Oh, hey, good luck getting that kind of an interest rate nowadays. Interest rates nowadays on those savings accounts are 0.25%. Literally 1/10 of that. Yeah, banks. They tell you you need to save money, but they don't make it worth your while. Okay. Quarterly. Difference between annually and quarterly is how many times per year. Quarterly N would be what? 4 times a year. 3,200, 1 plus 0.024 over 4 times 4 times 7. How many times per year times the number of years? And you figure that out, and you'd make a little more money. 3,700 83 50. Ooh, you'd make an extra a little less than $6 more. Woo! Yeah, we're rolling now. Monthly. What would N be for monthly? 12. What would weekly be? 52. 52 weeks in a year. Okay. Do monthly, weekly, and do continuously. Use the continuous compounding equation. So monthly, 3,200 times 1 plus 0.024 over 12 to the 12 times 7 power, and you end up getting 3784.76. An extra $1.25. When you do it weekly, 3,200 times 1 plus 0.024 over 52 times 52 times 7th power, and you get 3785.25, an extra 50 cents, and compounded continuously. 3,200 e to the 0.024 times 7, and 3785.39. Ooh, an extra 14 more cents. Yeah, compounding continuously, unless you have a significant investment, it doesn't make any difference. It's really not that much. So having the banks do it even if you see difference between quarterly and continuously is so little that unless you have several $100,000 for your investment, it's not going to make that much of a difference. If you have that kind of money to invest, you should not be putting it in a savings account anyways. You should be putting it in something that's going to have a better yield. Okay, if you have that money to put that much money to put away. Okay, question. Okay, now there is the little box. I think, but I am not sure if I did it on yours. Is there a bigger one? No. No, I'm sorry, my bad. You can read them up here too. Okay, so these are just application problems. So what we did, you're using the same formulas. Okay, how much principal should you invest at 5.9% compounded quarterly to return $7,400 after 8 years? So, same formula. Only we're looking for what the investment is, not the final amount. So that would be 7,400 equals P times 1 plus 0.059 over 4 to the 4 times 8 power. Because you're compounding quarterly. Now, what I did, figure out what that is, what's in the parentheses, take it to the 32nd power. 7,400 equals 1.59768 P. Carry it out to several decimal places. That's what I did. Divide both sides by 1.59768, and the principal you get, you would have to invest $4,631.71. Not that hard to do, relatively speaking. Next one actually starts out fairly easy. This is a common problem. You borrow $150,000 at 6.5% interest. Say you're buying a house. And you've got money for the down payment. You need to borrow an extra $150,000 to be able to buy the house. Generally speaking, when you buy the house, you do not take a loan for the entire price of the house. Most banks will not do that. There are rare exceptions. Those rare exceptions will cost you through the nose. Usually you have to come up with a down payment. The better down payment you have, the better your monthly payments are going to be on the loan you have. The smaller the loan, the better interest rates you're going to be. They're more willing to work with more money that you can come up with. So this would not be unreasonable to buying a house that this is the part you have to take the loan out on because you've already got the down payment. Okay, and this is what's left to buy. Okay, or a motor home or whatever. 6.5% interest rate. It's not great. It's not horrible. Okay. And you agree to pay the loan off in 4 years. That's pretty good. Paying it off in 4 years, that's a pretty good payment rate. You're going to be making some big payments on that. Okay. How much interest will you have paid? So the idea is you figure out what the total amount you're going to pay back is. What the total amount you're going to pay back is, the original loan, $150,000, as if that were your investments that you're making. So it'd be 150 times 1 plus 0.065, and you're doing it compounded monthly, so that's 12 months. So 4 times 12 here. So you're figuring out what your total payment's going to be. When you're all said and done, how much are you going to pay? You do it the same way as if you were figuring out the interest on how much money you'd have in a bank account if you were saving at that rate. That's how much you're going to be paying total. So the amount you're going to be paying total, you figure that out, is $194,403.07. That's what you're going to pay back. However, that is not my answer. Because the answer is how much interest will I be paying, right? So what do I need to do? Subtract 150,000 from that. Subtract the original loan amount from that. And you do that, and you'll be paying back $44,403.07. Right? No, wait. Yeah, 7 cents. So you're going to pay $44,000 more on that loan. This is the reality of the situation. Unless you have cash to pay cash for something, you know, and this is where homes and cars and things like that, they can get expensive in a hurry. This is not just the price of the vehicle, it's the price of the vehicle over the time you paid the loan. Okay? It's nice to be able to afford to go and pay cash for everything. Not a lot of people can pay cash for everything right up front. Yes?
Isn't that like if you paid all of the money at once though instead of like paying off?
No, that's paying off over time. Most loans nowadays, you do. It used to be you'd have a penalty for early payments, which meant if you paid it off early, you'd be basically still paying that total amount anyways. Nowadays, if you pay more than your minimum payment, that extra you pay in goes towards the principal, not towards the interest you're paying. And that will help you pay it off faster with less interest that you're paying. So let's say I had this loan, $150,000, and I agreed to pay like $5,000 a month. If I pay $5,000 a month, I'm paying back the $150,000 plus the $44,000 over the life of the loan. That's how much I'm paying. Okay. If I paid it off early, let's say instead of paying $5,000 a month, I was able to pay $7,000 a month. That extra $2,000 a month would go towards my principal, so my interest would be less. Okay, because each payment is broken up into the interest and principal. How much the principal are you paying off, and how much interest are you paying off on this particular payment? If you pay more than the interest amount, everything towards that goes towards the principal. That's basically, California really protects consumers, but that's pretty much everywhere nowadays. No penalties for early payment. That's an important thing to check. Make sure you have that you can pay it off early without penalty, which means you're saving money. And they don't mind. They're getting their money faster. They can go on to something else. It's not that big a deal. It really isn't, because they're still going to get some interest off you anyways. And they like it, and you're a secure loan. You get good credit, you're going to borrow more money later because you got a security, because you got good credit. So yeah, it's one of those things. It's tricky. Believe me, I'm not an expert on this either. I let my wife make the financial decisions. I have a degree in math, but I let her make the financial decisions because she's better at it than I am. Just saying. Okay, next one. Cheryl invests $400 at 9% compounded continuously. How many years to the nearest tenth will it take to double the investment? I like doubling problems. Okay. Let's set it up. If she invests $400, what's twice that? $800. So it would be $800 is equal to 400, and it says continuously, so that's e to the 0.09 t. What's my first step? Divide both sides by 400. So you get 2 equals e to the 0.09 t. This is doubling. Whenever it says doubling, this is what you'll get every single time after the first step. 2 equals e to, or whatever the thing is without the original investment amount. This is what you always have every single time. Now, solve this the way we were doing them earlier. There's a couple of ways to do it. You can loop it. You can take the natural log of both sides. Either way, you get 0.09 t is equal to the natural log of 2. So t equals the natural log of 2 divided by 0.09, and to the nearest tenth, 7.7 years. Which is about pretty close. 7 years, give or take, is usually about doubling. Give or take, depends upon the interest rate. There's actually a formula for for how long it'll take based on the interest rate to double, which is actually the natural log of 2 divided by the interest rate. That'll give it to you every time. Now, one more to go, it actually, because it repeats the same problem twice. So you don't have to go any more than one more. Yeah, because it is on there twice. I don't know why it's on there twice. Okay, an investment of $4,000 compounded quarterly at 8% interest will take how many years to be worth $10,000? So that means 10,000 equals 4,000 compounded quarterly, 1 plus 0.08 over 4 to the 4t. That's your setup. Once you go from there, it's arithmetic using your calculators. Divide both sides by 4,000. So you get 10 over 4, which is 0.25. Oh, sorry, 2.5, my bad. 2.5 is equal to, and then you figure out all of this inside here, 1 plus 0.08 over 4, and then it ends up being 1.02 to the 4t. So it's inside the parentheses to the 4t power. Now I've got an exponential. How do I solve that? I take the natural log of both sides. Take the natural log, take the natural log. On this one, take the 4t, bring it out in front. So you get 4t natural, I'm actually going to rewrite this one here. T times 4 natural log of 1.02 is equal to the natural log of 2.5. Because to bring the power down in front, I want to move the t in front of the 4. Divide both sides by 4, natural log of 102. T equals the natural log of 2.5 divided by 4 times the natural log of 1.02, and you get 11.57 years. So it'll take about 11 and a half years. 11 years and 7 months-ish. Not bad. Questions? Learn the formulas. Know the formulas.